January 1942. The humid air above southern Australia carried the distant echo of a war that was spreading faster than anyone could contain. The fall of the Philippines had sent shockwaves through the Allied command. American bombers, once symbols of air superiority, were now scattered relics of a retreat across the Pacific. On the tarmac of RAF Laverton, near Melbourne, one such relic stood motionless, a B-17D Flying Fortress, serial number 40 to 3097. It had limped back from the chaos of the Dutch East Indies, its fuselage torn by shrapnel, its tail half shattered from a forced landing, its engines worn thin by months of non-stop evacuation flights. The aircraft looked more like wreckage than war machine. The aluminum skin was pitted and warped, the nose cone blackened by oil and exhaust. Inside, the smell of burnt fuel lingered. Bullet holes traced uneven constellations across the wings, and control cables hung loose where they had snapped under stress. For the ground crews who saw it arrive, the verdict seemed obvious: the fortress was finished. In the brutal arithmetic of wartime logistics, such a machine was not worth saving. Australia was now a frontline base, and every spare hour, every gallon of fuel, every part had to serve the planes still capable of flying. Yet, among the scattered debris of war, there was one man who saw something different. The mechanics assigned to the repair depots at Laverton were used to improvisation. They had been patching together machines with whatever metal and tools they could find. Supply lines from America were weeks away, and the 19th Bombardment Group depended on every aircraft they could resurrect. In those desperate days, survival meant invention. The B-17D before them was a challenge of another scale. It had survived its journey across half the Pacific, hopping from Java to Darwin and finally to Melbourne, often under enemy pursuit. Its tail had taken the worst of the damage, nearly breaking off upon landing. Some suggested stripping it for parts to keep other fortresses alive. But others hesitated. The Flying Fortress was more than a bomber. It was a symbol of endurance. If any plane deserved another chance, it was this one. As the southern summer sun burned over the runway, the aircraft cast a long, broken shadow across the concrete. It was a monument to the early chaos of the Pacific War, when the Allies fought not only the enemy but also exhaustion, shortage, and doubt. Around it, teams of mechanics worked silently, some shaking their heads, others sketching ideas in the dust. The hangars were filled with other crippled machines, Hudsons, P-40s, and B-17s awaiting miracles. But this one drew special attention because of its sheer defiance. Days passed. The bomber remained parked, its wings drooping, its fate uncertain. Then a rumor spread across the base: the damaged fortress would fly again. Few believed it possible. The tail was beyond repair, the parts non-existent. But in a war where defeat was measured in lost machines and lost morale, even the idea of revival was worth pursuing. What happened next would turn this battered aircraft into one of the strangest symbols of the war. From the remains of another wrecked B-17, mechanics would graft a new tail onto the old frame, creating a hybrid machine that defied every regulation in the book. When it finally rose from the runway weeks later, patched, mismatched, and undeniably alive, it carried a name that reflected its strange rebirth: the Swiss half-swan, half-goose. That flight out of Laverton marked more than the survival of a single aircraft. It marked the moment when improvisation became strategy, when repair became resistance, and when one flying fortress, held together by bolts, faith, and human stubbornness, embodied the resilience of an entire generation learning how to fight back. In the first months of 1942, the Pacific War placed the United States Army Air Forces in a position of near collapse. The 19th Bombardment Group, once proud and well-equipped in peacetime, had been battered into exhaustion. Its squadrons had fled from Clark Field in the Philippines under Japanese attack, abandoning hangars full of burning aircraft. Those that managed to escape did so only by hopping from island to island across the Dutch East Indies, carrying the scars of every encounter. By the time the survivors reached Australia, their flying fortresses were no longer symbols of strength but reminders of how fragile modern war could be. The 19th had begun the war with 35 operational B-17s spread between Mindanao and Luzon. Within weeks, Most of them were gone, destroyed on the ground, shot down during bombing runs over Formosa and Borneo, or forced to crash land on improvised runways. The retreat across the archipelago left behind not only wrecked aircraft but also the entire infrastructure needed to keep them alive. Machine shops, maintenance crews, spare parts, and fuel depots had been wiped out or captured. What arrived in northern Australia in January 1942 was a small and weary fleet, carrying its own history of fire and improvisation. Among these survivors was the B-17D, serial number 40-3097. It had flown missions out of Del Monte Field in the Philippines and later out of Java, evacuating personnel and supplies as the Japanese advanced. The repeated long-range flights under heavy loads had strained its structure to the limit. Its tail assembly had been weakened by damage during a forced landing, the control surfaces were riddled with bullet holes. The engines had accumulated hundreds of hours without proper overhaul. Even the landing gear was unreliable, having been patched together multiple times in the field. By the time it reached Melbourne, the aircraft was physically and mechanically spent. Australia itself was unprepared for this sudden influx of crippled bombers. The repair depots at RAF Laverton and Amberley were never designed to handle American heavy aircraft. The tools were insufficient, the hangars too small, and the technicians untrained for the complex systems of the Flying Fortress. Communication with the Boeing factory in Seattle was slow, and replacement parts were months away by sea. In early 1942, a single crate of spare components could mean the difference between an aircraft flying or being scrapped. Commanders faced impossible arithmetic. Every usable bomber could contribute to reconnaissance, supply, or morale. Every loss meant another hole in a defense already collapsing. But the reality was brutal. Rebuilding a B-17 in wartime Australia was like assembling a watch with a hammer and nails. Mechanics relied on scavenged parts, cutting panels from wrecks and welding braces by hand. Each plane that returned from Java brought not only its crew but also new problems: burned wiring, bent propellers, cracked fuel lines. The logical course would have been to strip the wrecked fortresses for spares, feeding one airworthy aircraft from the bodies of others. Yet this meant accepting a steady decline, a slow cannibalization of the fleet until nothing remained. That was the unspoken fear at Laverton, the idea that they might watch the last of the 19th's heavy bombers fade into silence before the reinforcements from America could even arrive. The B-17D 40-3097 represented that dilemma in its purest form. It was too damaged to fly and too valuable to destroy. The tail was nearly detached, the internal bulkheads warped, and the hydraulic system dead. Officially, it was beyond repair. Unofficially, it became a test of imagination. The ground crews began to discuss the unthinkable. Could two wrecked fortresses be joined into one? Could the tail of a donor aircraft, 40-3091, be fitted onto 40-3097's surviving fuselage? The problem went beyond engineering. It was about time, risk, and morale. The Americans in Australia were surrounded by uncertainty. Japan's expansion seemed unstoppable. Every successful repair was an act of defiance. If even one fortress could be brought back to life, it would prove that the U.S. air arm was not finished, that improvisation could stand in place of industry, and that human skill could hold the line until factories across the Pacific caught up with the war. Thus, the battered B-17D at Laverton was more than a broken machine. It was a question posed to everyone who looked at it, whether defeat would be accepted as mechanical fact, or challenged as something that could still be repaired. Before the war, the Boeing B-17 had been hailed as a masterpiece of American aeronautical engineering. Introduced in the mid-1930s, the Flying Fortress was designed to project air power far beyond the nation's borders, capable of carrying heavy bomb loads at high altitude and defending itself with multiple machine gun turrets. By 1941, its reputation was already growing in military circles, supported by newspaper headlines that celebrated its supposed invincibility. Yet the early variants, models B through D, were still transitional designs, produced in small numbers and lacking many of the refinements that would later define the famous B-17F and G models used over Europe. These early fortresses were pioneering machines, but in December 1941, they found themselves thrown into a theater for which they had never been intended. When Japan attacked Pearl Harbor and simultaneously invaded the Philippines, the 19th Bombardment Group was one of the few American heavy bomber units stationed west of Hawaii. Its aircraft were among the earliest B-17 CS and DS delivered, shipped across the Pacific in the months before the war. They were meant to deter aggression and demonstrate the long reach of American air power. Instead, they were caught in the chaos of an offensive that unfolded faster than logistics could adapt. The bases in the Philippines, Clark Field and Del Monte, were bombed within hours of the first attacks. Ground crews were killed or scattered, hangars destroyed, and spare parts burned in their crates. The early B-17s had not been built for the tropical, improvised warfare that now surrounded them. Their engines overheated in humid climates, and their landing gear suffered on rough airstrips cut into jungle terrain. Dust and salt air corroded aluminum and clogged carburetors. Without a steady supply of fuel and lubricants, maintenance became guesswork. Crews learned to improvise with hand tools and local materials, patching bullet holes with flattened food tins and wiring electrical systems from scavenged radios. What had been designed as a precision instrument of long-range bombing became, in practice, a survival machine. When the situation in the Philippines became untenable, the remaining B-17s fled south, operating from makeshift fields in Mindanao, Celebes, and Java. Their missions shifted from strategic bombing to desperate evacuation and reconnaissance. Each flight was a test of endurance, pushing airframes far beyond their intended limits. In these conditions, the line between flying and falling grew dangerously thin. Mechanics cannibalized wrecked fortresses for usable components, creating hybrid aircraft held together by rivets, wire, and luck. By early 1942, the survivors that reached Australia were veterans of a retreat unlike any in modern aviation history. They carried the accumulated fatigue of months in combat without proper overhaul. Their aluminum skins were patched in dozens of places, their engines burned oil at alarming rates, and their gun turrets jammed from corrosion. The Australian facilities that received them, primarily RAF bases at Laverton, Amberley, and Townsville, had no prior experience with American heavy bombers. Australian and American personnel worked side by side, often without manuals, relying on intuition and memory. In this environment, the distinction between maintenance and invention disappeared. Technicians became engineers by necessity. They learned to manufacture gaskets from rubber flooring, to mold replacement panels by hand, and to substitute local materials where original parts did not exist. The Royal Australian Air Force provided workspace and equipment, but the ingenuity came from individuals who refused to let the machines die. It was within this broader story of adaptation that the B-17D serial number 40-3097, later to be called the Swiss, was reborn. The idea of reconstructing one damaged aircraft from the remains of another was not merely a technical challenge. It was the embodiment of a larger truth about the Pacific War. The United States had entered the conflict unprepared for its scale, and the men stationed thousands of miles from home had to improvise to survive. The early months of 1942 were marked by shortages, confusion, and retreat, yet also by flashes of creativity that would come to define the Allied response. The repair depots in southern Australia became small laboratories of wartime innovation. They were the first places where American air power learned to function without its industrial backbone, to fight not with abundance but with resourcefulness. The B-17s that emerged from these workshops were imperfect, patched, and asymmetrical, but they flew. And in the desperate early months of the Pacific Campaign, that was enough to keep hope alive. The story of the Swiss began in this world of improvisation, where metal fatigue met human determination, and where the future of Allied air warfare depended on the ability to turn wreckage into strength. At the start of 1942, the repair bays at RAF Laverton had turned into a graveyard of machines. Dozens of battered aircraft stood silent, each telling its own story of escape, defeat, and survival. Among them were two B-17DS that seemed beyond saving, serial numbers 40-3097 and 40-3091. Both had endured the retreat from the Philippines and the desperate flights through Java to Australia. Both had limped in on failing engines and fractured frames. And yet, when the mechanics inspected them closely, they realized that between these two wrecks, there might still exist one complete airplane. The first of the pair, 40 to 3097, had suffered severe structural damage to its tail section. The force of a rough landing in Java had twisted the rear fuselage and buckled its internal ribs. The stabilizers and rudder were barely attached, their control cables frayed and useless. The second, 40 to 3091, had been less fortunate at the front. Its nose and wings were ruined, but its tail was intact, cleanly severed from the rest of the fuselage after an accident during ferrying operations. In any normal circumstance, both aircraft would have been written off, stripped for salvage, and quietly removed from the records. But war erased the concept of normal. Every aircraft in Australia was needed, every hour counted. The idea of merging the two wrecks was born out of necessity, not theory. There were no official manuals describing how to splice the fuselage of one B-17 onto another. Boeing engineers, half a world away in Seattle, could not be consulted in time, and even if they could, there were no spare assemblies to replace what had been lost. The mechanics on the ground had to rely on judgment, measurement, and courage. What they were proposing was as much art as science: to cut off the damaged rear of 40 to 3097 and graft in the surviving tail of 40 to 3091, aligning two heavy aluminum structures down to the millimeter so that the new frame could bear the stress of flight. The decision to attempt the operation was not taken lightly. The 19th Bombardment Group's technical officers understood the risks. A misalignment of only a few degrees could cause catastrophic instability in the air. But they also knew the alternative, losing another fortress, was unacceptable. The Pacific Front had no reserves, and morale among air crews was already strained by the constant sight of grounded bombers. To see one rise again from wreckage would mean more than just an additional aircraft. It would be a statement of persistence. Thus began what became one of the most daring repair projects of the early war. The Australian workshops were cleared, and both airframes were hauled inside. The crews began the meticulous process of disassembly, measuring the diameters of bulkheads and the spacing of stringers, comparing every rivet line between the two halves. They discovered that although the B-17DS were built to the same design, each aircraft had minor variances from hand assembly at the Boeing factory. These small differences would make the grafting operation complex. To compensate, they fabricated custom joint plates and reinforcement ribs from salvaged sheet aluminum, shaping them by hand over wooden molds. The cut on 40-3097's fuselage was made just aft of the bomb bay, where the structural loads were lowest. The tail section of 40 to 3091 was trimmed to match, its edges sanded and drilled for alignment bolts. With improvised hoists and ropes, the mechanics lifted the replacement tail into position, guiding it carefully until the frames sat flush. For several days, teams worked in shifts, installing rivets, reinforcing bulkheads, and rewiring the control systems. In a quiet corner of the hangar, observers from both the U.S. Army Air Forces and the Royal Australian Air Force watched with fascination. They knew they were witnessing something unprecedented, not a repair, but a reconstruction. The mechanics were effectively building a new aircraft without factory tools or blueprints, guided only by experience and instinct. When the two halves were finally joined, the hybrid machine stood out among the rows of battered aircraft. Its metal skin bore two distinct shades of silver, its serial numbers no longer matched. But it was complete. For the first time in weeks, the crews at Laverton looked upon a B-17 that had been dead and was now whole again. The grafting of 40-3091's tail onto 40 to 3097 was more than a technical feat, it was an act of defiance. It symbolized the moment when desperation turned into innovation, when rules gave way to necessity. The mechanics understood that the experiment might fail, that the first flight could tear the fuselage apart. Yet they also understood that in those uncertain days of 1942, the true measure of courage was not in destroying the enemy, but in refusing to give up on what could still be made to fly. This single decision, to attempt the impossible and rebuild a fortress from fragments, became the turning point in the story of the Swiss. It was the moment when the boundaries between engineer and soldier blurred, and when human determination began to rival the machinery it sought to restore. The reconstruction of the B-17D at RAF Laverton became a small epic of wartime engineering. The airfield, located on the outskirts of Melbourne, had been transformed into a repair hub for the battered remnants of the U.S. 19th Bombardment Group. Its hangars were filled with the smell of oil, scorched aluminum, and welding fumes. Australian and American personnel worked side by side, improvising solutions far beyond anything their training manuals had prepared them for. There were no precision jigs, no specialized factory tools, and no supply chain to lean on. Everything had to be done by hand, with the materials available. The project began with disassembly. Mechanics stripped the rear fuselage of aircraft 40 to 3097 down to its structural frame, cutting cleanly across the bulkhead just behind the bomb bay. The jagged remains of the original tail were removed, and the damaged ribs and stringers were replaced or straightened. The donor section from 40 to 3091 was hauled into the hangar on a flatbed truck, its aluminum surface dull and sand-scoured from exposure. The two halves looked mismatched even at first glance, one slightly darker from oxidized metal, the other newer in appearance, but measurements confirmed they could be joined. Working from chalk lines drawn on the hangar floor, the engineering team established the precise center line and angle of incidence. Alignment was everything. If the new tail sat even a few millimeters off axis, the entire aircraft would twist under flight stress. Using wooden scaffolding, chain hoists, and a network of jacks, the mechanics slowly raised the replacement tail into position. The operation took hours of incremental adjustment. Crewmen stood on ladders, checking symmetry by eye, comparing panel edges and rivet rows under the dim light of overhead lamps. Once aligned, the fusion of the two airframes began. The mechanics fabricated joining plates from spare aluminum sheets scavenged from other wrecks. These plates acted as skeletal bridges between the two fuselages, riveted in overlapping patterns that distributed stress across the seam. Reinforcement ribs were cut by hand from scrap material, shaped over wooden molds, and bolted into place with improvised fasteners. The men worked in shifts, sleeping in the hangar and eating at makeshift benches while the sound of hammering echoed through the night. Beyond the structural repair, every subsystem had to be reconnected or re-engineered. Control cables from the cockpit to the rudder were rest-strung through the hybrid fuselage. Hydraulic lines were rerouted and tested under pressure for leaks. Electric wiring, charred from previous overloads, was replaced with new circuits built from spare copper salvaged from grounded aircraft. The oxygen system was inspected, the bomb racks were removed to lighten the plane's weight, and the fuel tanks were resealed with a compound mixed on site from local materials. Simultaneously, attention turned to the engines. The four Wright R-1820 Cyclones had run for hundreds of hours without overhaul, and their bearings were near failure. Mechanics disassembled each one, cleaning carbon deposits from pistons and valves, improvising gaskets from sections of rubber flooring, and crafting replacement fittings on hand-operated lathes borrowed from the Australian side of the base. It was crude work by industrial standards, but it reflected the resourcefulness that wartime scarcity demanded. The outer skin of the aircraft became a patchwork of colors and textures. Some sections gleamed silver where new metal had been applied, others remained dull, streaked with oil and soot. The original U.S. insignia had been partly sanded away during the repairs, and hastily repainted markings stood crooked on the mismatched panels. Mechanics joked that the plane looked like two fortresses welded together by committee, and in truth, that was not far from reality. Despite the rough appearance, the finished aircraft was structurally sound. The joining seam was reinforced with hundreds of rivets and additional steel plates to handle aerodynamic stress. When the final inspection came, engineers tested every system methodically. The tail surfaces moved freely, the hydraulics responded cleanly, and the fuselage held pressure under vibration tests. For the first time since Java, the airframe stood whole and balanced on its landing gear. The mechanics gathered at the end of the runway to look at their creation. It was unlike any flying fortress they had ever seen, a hybrid of two broken machines, asymmetrical and awkward yet undeniably alive. Someone among them remarked that it looked like a goose trying to be a swan, a comment that drew laughter in the hangar. The nickname stuck instantly. From that day forward, the rebuilt B-17D carried the strange but fitting name, the Swiss, a combination of swan and goose. The engineers could not have known it then, but the name captured the essence of what they had achieved. The aircraft was neither factory perfect nor entirely original, but something in between, an emblem of adaptation in the face of scarcity. Its patchwork body told a story written in metal and rivets, that even in war, ingenuity could breathe life back into what the world had already declared lost. The first test flight of the reconstructed B-17D took place in early March 1942, under a pale Australian morning sky. The mechanics at RAF Laverton gathered along the edge of the airstrip, their faces drawn with fatigue and expectation. Weeks of work had led to this moment. The hybrid aircraft, half 40 to 3097, half 40 to 3091, stood gleaming unevenly in the light, its mismatched panels reflecting the dawn. Its presence was both a triumph and a question. No one truly knew if it would fly. The pre-flight inspection lasted hours. Every control cable was checked for tension, every hydraulic line for leaks. Mechanics crawled under the fuselage, tapping rivets with hammers to listen for weak joints. The engines, for Wright R-1820 Cyclones, were started one by one, their propellers spinning in uneven rhythm before settling into a synchronized roar. The hangars trembled as the combined sound filled the airfield. Observers noted that the tail section, though visibly distinct in tone and rivet pattern, showed no sign of vibration or structural flexing. It was a promising beginning. When the pilot advanced the throttles, the aircraft rolled forward with surprising steadiness. As it lifted off the runway, there was a collective silence on the ground. The hybrid B-17D rose slowly but cleanly, climbing over the eucalyptus trees at the edge of the base. The tail held firm, the rudder moved evenly, and the wings remained level. Against every prediction, the grafted airframe behaved like a single, unified machine. The first flight lasted less than an hour. The pilot maintained a wide circuit over the fields outside Melbourne, avoiding sharp turns or sudden maneuvers. Engineers on the ground tracked the aircraft through binoculars, watching for any abnormal flex or flutter in the tail. None appeared. When the plane descended and touched down smoothly on the same runway it had left, the crews erupted into applause. Their experiment had not only worked, it had produced a fully functional aircraft. In the following days, further tests confirmed the integrity of the rebuild. The control response was stable, the vibration levels low. The weight distribution differed slightly from factory specifications, but the B-17's robust design absorbed these differences without strain. The hybrid plane was slower by a few knots and carried a subtle yaw to the left, likely due to alignment variances, yet these quirks were minor compared to what had been expected. With the test program complete, the aircraft was officially returned to service under the U.S. Army Air Force's inventory. It was redesignated for transport and liaison duties rather than combat bombing. Its bomb racks were removed, replaced with additional seating and cargo storage. A defensive armament of waist guns and a tail turret remained, enough to protect against isolated threats along Australia's northern coast. In its new role, the Swiss began operating as a communication and navigation escort aircraft, linking bases across the vast distances of the Australian continent and New Guinea. It carried officers, supplies, and spare parts between airfields too remote for standard transports. Often it escorted ferry flights of newly arrived bombers or reconnaissance aircraft, acting as a flying guide for crews unfamiliar with the terrain. The hybrid fortress became a familiar sight at outposts such as Townsville, Charters Towers, and Bachelor Field. Its performance was modest compared to newer aircraft arriving from the United States, but reliability, not speed, was what mattered. The mechanics who had built it watched with quiet pride as their creation endured repeated missions, logging flight hours that no one had dared expect. Despite its unconventional birth, the Swiss proved remarkably resilient. The reinforced joint between its two halves showed no fatigue cracks, even after weeks of operations. Ground crews performed regular inspections, and though minor oil leaks and mechanical wear were common, the aircraft never failed structurally. By mid-1942, as fresh B-17E and B-24 bombers began arriving in Australia, the Swiss had already carved out a new identity. It was no longer just a patched-together survivor, it had become a dependable workhorse of the Allied rear areas. It flew routes that crossed tropical storms, dust-choked inland deserts, and coastal patrol zones, providing a vital link in the fragile logistics chain that sustained the early Pacific campaign. Every takeoff carried symbolic weight. The aircraft represented more than recycled aluminum and bolts. It stood for the triumph of field ingenuity over material shortage. Pilots trusted it, crews maintained it with reverence, and those who had seen its reconstruction regarded it as proof that skill and persistence could overcome even the ruin of war. When other early model B-17s were scrapped or abandoned as obsolete, the Swiss kept flying. It survived because it was never just another machine, it was the embodiment of a principle that guided the Allied war effort in those desperate years. If something could be made to work, it would. And as long as the Swiss stayed in the air, it reminded everyone who saw it that determination could, quite literally, take flight. The success of the Swiss at RAF Laverton resonated far beyond the boundaries of a single airfield. In early 1942, when the Allied forces in the Southwest Pacific were still struggling to reorganize after a string of defeats, the rebirth of a broken B-17D into a fully functional aircraft became both a technical and psychological turning point. The repair proved that heavy bombers, even when severely damaged, could be resurrected far from factory support. It showed that engineering creativity could substitute for industrial abundance, and that morale itself could be built out of rivets and persistence. The story spread quickly through the American units stationed in Australia. Maintenance officers of the 19th Bombardment Group, impressed by the ingenuity of the Laverton team, began to apply similar methods to other grounded aircraft. Crews at Amberley, Townsville, and Bachelor Field learned that donor airframes could be combined, that parts once thought unusable could be reshaped and repurposed. What had begun as an act of improvisation turned into a method of survival. Mechanics in other depots began referring to such procedures as Swiss repairs, a quiet tribute to the patched-together fortress that had defied its fate. The effect was not merely technical. In a theater where defeat had seemed inevitable, the Swiss became a symbol of endurance. For aircrews facing relentless missions over New Guinea and the Coral Sea, its continued flight served as a reminder that resilience was not theoretical. It could be seen taxiing down a runway. Soldiers visiting Laverton would stop to look at the odd, mismatched aircraft whose tail bore different shades of aluminum. It looked unlike any other bomber in the inventory, but that imperfection became part of its legend. The aircraft's reputation grew further when it proved itself on long-distance liaison missions. Its hybrid construction did not limit its performance. On the contrary, it demonstrated impressive range and reliability. Word reached higher headquarters, and by mid-1942, the unusual plane had caught the attention of General George H. Brett, the commander of Allied air forces in the Southwest Pacific area. Brett, who had been tasked with holding together the fragile coalition of American and Australian air units, needed a dependable personal transport to cover the vast distances between bases. The Swiss, with its proven reliability and extra fuel capacity, fit that role perfectly. The bomber was stripped of most of its remaining armament and fitted with additional seating, communications equipment, and navigation aids. It was repainted with modest markings and assigned to carry General Brett and his staff on inspection tours throughout Australia, New Guinea, and the Coral Sea region. The transformation was deeply symbolic. The same machine that had once escaped destruction and been reborn from the remains of another now carried the man responsible for directing the Allied air campaign in the Pacific's most uncertain period. The irony was not lost on those who remembered the aircraft's origin. Mechanics who had worked on the rebuild watched with pride as the plane they had once pieced together from scraps now taxied out of Laverton with the commanding general aboard. In its patched fuselage was embodied the story of the early Allied war effort. A story of making do, of refusing to accept loss as permanent, of treating every broken thing as something that might still be repaired. Under Brett's command, the Swiss logged hundreds of flight hours in 1942 and 1943, visiting forward bases and carrying vital dispatches. It became a familiar sight across the region, instantly recognizable by its uneven panels and distinctive profile. Pilots joked that it was the ugliest fortress in the sky, but they said it with respect. Its reliability made it famous, and its name, half swan, half goose, captured the strange dignity of its transformation. The success of this aircraft encouraged a broader cultural shift within Allied maintenance philosophy. The lesson of the Swiss was simple yet profound: ingenuity could be institutionalized. Field depots were encouraged to innovate rather than wait for perfect solutions. Engineers documented their methods for splicing fuselages, adapting non-standard parts, and reinforcing damaged structures. The practice of reusing components from wrecks became an accepted part of sustaining air operations in the Pacific. As newer bombers like the B-17E and B-24 Liberator began arriving in greater numbers, the days of desperate improvisation slowly ended. But the Swiss remained a living reminder of that era. Even when it was eventually replaced as General Brett's aircraft and assigned to transport duties in the United States, its reputation followed it. Veterans of the early Pacific campaigns spoke of it not as a curiosity but as proof that leadership and survival often depended on the same quality: the ability to adapt. By the end of the war, the impact of the Swiss had outlasted its operational service. It influenced the mindset of airmen who learned that victory was not always achieved through power alone but through resourcefulness, collaboration, and belief in the possible. What began as a desperate repair at a quiet Australian base had become a symbol for an entire generation of mechanics and pilots who learned that even in war, creation could be an act of courage. After the war, the Swiss followed a path as unlikely as its creation. When the guns fell silent in 1945, thousands of flying fortresses were scrapped, melted down into raw metal to feed the peacetime economy. The majority of the early B-17 variants, especially the C and D models, had already disappeared, lost in combat or broken down for parts. But by a series of coincidences and quiet acts of preservation, the hybrid aircraft that had once symbolized survival in Australia escaped that fate. It became the last surviving example of the B-17D and one of the oldest flying fortresses in existence. Its post-war life began in relative obscurity. By late 1943, the Swiss had been transferred from the Pacific to the United States, where it was assigned to various transport and administrative duties. When General George Brett returned home after his service in the Southwest Pacific, he arranged for the aircraft that had carried him through the early years of the war to continue serving as his personal transport. The plane was repainted in U.S. markings, its patched fuselage cleaned but never fully restored. Inside, the interior was modified for passenger use rather than combat, giving the once battle-born machine a quieter role in the post-war air service. In 1946, as newer aircraft replaced the older B-17s, the Swiss was finally retired from active military service. Many of its contemporaries were already being cut up for scrap at airfields across America. Somehow, through Brett's intervention and the efforts of sympathetic officers, the aircraft was spared. It was stored at various depots, moved occasionally for display or inspection, and gradually became a curiosity, a relic of the first, uncertain year of the Pacific War. Over time, its values shifted from utility to heritage. In the early 1950s, the aircraft found a caretaker in the city of Los Angeles, where it was displayed briefly as a war memorial. Later, it was moved to Andrews Air Force Base in Maryland, where it sat outdoors for years, exposed to the weather but still intact. Visitors who saw it often remarked on its unusual appearance: the patchwork tail, the asymmetrical panels, the strange balance of elegance and endurance. To those who understood its story, those imperfections were sacred scars, physical records of human ingenuity in the face of collapse. By the 1960s, as interest in aviation history began to grow, veterans and historians recognized that the Swiss was not merely another surviving aircraft. It was a living artifact that connected the earliest days of the war to its victorious end. It had flown in both hemispheres, served under multiple commands, and embodied the transition from desperation to dominance. Efforts began to ensure its preservation. In 1961, the aircraft was officially transferred to the Smithsonian Institution, but due to space and resource limitations, it remained in storage for years. Eventually, in 1978, the Swiss was moved to the National Museum of the United States Air Force in Dayton, Ohio. There, curators began a long-term preservation program focused not on polishing or idealizing the aircraft, but on maintaining its authenticity. The goal was not to make it shine like new but to keep it honest, to let its scars, mismatched panels, and welded seams tell their story. Every rivet line and every patch of faded aluminum remained visible, a testament to the conditions under which it had been rebuilt more than 3 decades earlier. As restoration work continued into the 21st century, the Swiss gained renewed recognition among historians and engineers alike. It became a subject of study for those interested in wartime improvisation, field engineering, and the evolution of aircraft maintenance practices. Aviation scholars pointed to it as a physical embodiment of the make do and mend philosophy that had defined Allied survival in 1942. To visitors at the museum, the aircraft offered something deeper than nostalgia. It offered a tangible link to a time when victory depended not on abundance but on adaptation. Today, the Swiss stands as the oldest surviving flying fortress in the world. It predates every other B-17 still in existence, carrying with it the lineage of an era when human craftsmanship, rather than industrial power, determined the outcome of battles. Its lopsided beauty remains untouched by restoration gloss, its metal skin still bearing the seams of its improbable rebirth. The aircraft's legacy is not one of perfection but of perseverance. It survived because people refused to let it die, and in doing so, it became a monument to their refusal to surrender. Each dent and rivet line preserves a story of hands that rebuilt, improvised, and believed that something broken could still serve. In that sense, the Swiss remains more than a museum piece. It is a message in metal, a quiet voice from the past reminding those who stand before it that resilience is not about being unscarred, but about continuing to fly despite the damage. The story of the Swiss stood as one of those rare moments in history when technology and humanity merged into a single act of defiance. It was not the tale of a perfect machine, nor of an extraordinary invention, but of persistence carried to its purest form. Built from the broken halves of 2 bombers, it was proof that survival could be engineered by will alone. In an age defined by destruction, its existence became a quiet contradiction, a reminder that even in war, creation was still possible. The hybrid fortress represented more than a mechanical achievement. It embodied a philosophy that underlay the Allied victory itself, that progress was not only about building new things, but also about refusing to abandon what was already there. In early 1942, when the Pacific Front seemed to crumble under Japanese advance, the Swiss was a physical manifestation of resilience. Every rivet that held it together symbolized an act of resistance against despair. The men who rebuilt it did not simply restore an aircraft. They challenged the idea that something damaged was worthless. Its patchwork fuselage told a truth rarely captured in official histories. Wars are not won by the flawless or the unbroken, but by those who can continue despite imperfection. The smooth symmetry of a factory line could not exist in the chaos of the Pacific War. What did exist were tired hands, bent metal, and the will to make something fly again. The Swiss became a monument to that kind of courage, the kind that finds dignity in repair, in patience, and the refusal to let an ending be final. As decades passed and the aircraft's metallic skin dulled with age, its meaning deepened. It came to represent not just one moment of ingenuity, but a broader human truth: endurance is not the absence of failure, but the mastery of it. The Swiss carried within its riveted seams the story of countless soldiers, engineers, and civilians who lived through the uncertainty of war and found ways to rebuild their worlds afterward. It was, in its own way, a prophecy for peace, that what survives through damage is often stronger than what was never tested. In the context of the 20th century, dominated by mass production and mechanized destruction, the Swiss reminded those who studied it that value does not always come from uniformity or perfection. It came from adaptability, the same quality that allowed democracies to outlast dictatorships, and free societies to recover from ruin. The machine that had once been deemed impossible to save outlasted the empire that sought to destroy it. Inside a museum hangar decades later, the aircraft's presence invited quiet reflection. It stood not polished and restored to factory shine, but preserved as it was, uneven, scarred, honest. Visitors could trace their fingers along the mismatched panels and understand that every imperfection had once been a solution, every dent a mark of endurance. It no longer needed to fly. Its story had already done that for it. Through the Swiss, one could glimpse the paradox of human progress. The same species that built machines of destruction also found meaning in the act of mending them. The same war that tore the world apart also produced the determination to piece it back together. The patched metal of the B-17D was, in that sense, a metaphor for civilization itself, flawed, fragile, and endlessly repaired. And so, long after its engines fell silent, the Swiss continued to speak, not in sound, but in form. It stood as a reminder that resilience was not born of perfection but of persistence, that survival was not a matter of luck but of effort, and that hope could be assembled from fragments. Its riveted seams, illuminated by museum light, carried more than the memory of war. They carried the proof that even from the wreckage of destruction, something enduring could still take shape and remain aloft in human memory forever.